This is the log Q appear here because you express how you say, the matrix in the big field. Okay, I will not give you detail, but the rank is relatively low. Remember that we have to force this to be very low. Okay, all right. So this is a very important program. Appear in many instances. For instance, in RAM decoding rank metric codes. The metric codes are very important. The other day they will explain what is the codes, but metric codes they are codes in which the elements of the codes are already the vector of codes are the column vector. That means that then, in fact, the code is a matrix. Okay? And then the distance in this case with the two vectors is the rank of the matrix. Okay? So now the vectors are matrices, and the distance, the other day the distance was the number of entries of the vector that are different each other. In this case, as I say, the vector is formed by column vectors, and the distance is the rank. The distance between the two words B and C is equal to the rank of the matrix B minus C. They are, I mean, in two words, what are the rank? They are very important. Okay, and then again, the coding is again is to find a minimal distance. Is again fine combination with minimal rank. Okay, but there are many other applications. For instance, one application in coding theory also, a nice application is you have a matrix with some entries, A1, A11, A12, and you have a matrix that have several, a matrix M with several, is a matrix with several empty entries. Okay, so you have several places where you have, and then the problem is put fill these empty places in such a way that the rank is as low as possible. So fill the empty entries in such a way that the rank of the matrix is minimal. So you can see immediately that this is an instance of the mean rank problem. You can take the matrix plus lambda 1 for this, the identity matrix here, the matrix with 1 here, plus lambda 2 with a matrix with 1 here. And there. So really, and this is again, and this is very useful, for instance, for distributing information, or also what is called the Netflix problem. You know Netflix? Netflix is this company, a streaming company, okay? And for the Netflix problem, they wanted to see in the rating of the viewers. They wanted to see what are the points of a series of movies that are more important. Then they have a matrix in which you have some viewers and have some rating. So here you have a viewer with the rating, etc. But you have then several empty places. I mean, because of course not all viewers see all the movies. Okay, so see only a few of them, and then again fill this with low degree. With a low rank, gives you really some hint what are the more important digamos, points in which or aspects of the movie that are more important for the viewer. So this is again an instance of the mid-run problem. Okay, so I think maybe I will stop here. Again. Also, there is more extension, but I mean, how to say? But basically, many more extension of the idea of the SF with quadratic, but much of them can be at least attacked with the mean rank, but finally there is another. I will maybe in the tutorial will finally there is another important aspect of this multivariable is for signature. So I don't know. I have 5 minutes.
Yes.
Okay. Then I will explain how another. The main idea, how you use the signature, that construction of signature, that they are different. So how you make construction